Hello, welcome to the second and final midterm review homework assignment. Alright, let's take a look at what we have here. Number 1, the chart below compares two runners. Based on the information in this chart, state which runner has the faster rate, justify your answer. Alright, so again, this is coming from Unit 3. This is a proportion problem, and we're actually going to have to set up two proportions, one for Greg and one for Dave. So each person has 2 units. They have miles and hours. So why don't we start with Greg here. All right, I'm going to write my key. I'm going to do miles over hours. And it tells us that Greg goes 11 miles in 2 hours. So my first proportion is going to be 11 over 2. There's my first fraction. Equals... And then I want to know who has the faster rate, who goes the fastest, goes the furthest. So I'm going to say, how far does somebody go in just 1 hour? So I'm basically finding a unit rate here. How far do they go in 1 hour? Because that's effectively telling me their speed. It's telling me their rate. How far you go in 1 hour, or your miles per hour. So once we have this, it's just a question of cross-multiplying. So we get 2x equals 11, divide both sides by 2, and x is going to equal 5.5 miles. All right, so Greg goes 5.5 miles in an hour. Now let's see how far Dave goes. All right, so again, I'm going to set up the same type of key, miles over hours. This time it's 16 miles in 3 hours. So I want to know, how far does Dave get in just a single hour? So again, I've got my fraction set up here. If I cross multiply, I end up with 3x, equal sign just comes straight down, equals 16. Divide both sides by 3, and x is going to equal 5.3 repeating. Or I could also write that as 5/3, or I could also just put it as a fraction, 16 over 3. But I think having the decimals is helpful here so that we can compare the two situations. All right, so it says who has the faster rate. So if Greg's going 5.5 miles in an hour and Dave's only going 5.3 repeating miles in an hour, then we can say that Greg is faster. It's not by much, but Greg is a little faster in this scenario. Okay. All right, let's move on to number 2. All right, so no word problems here, just a more involved equation. So anytime you're dealing with these more involved equations, you just want to be thinking to yourself, DCMS. Start with your distribution. Then you want to combine like terms. Then you want to move the variable. And then after that, you should be ready to solve. Okay? So on this, if we start with our distribution, we've got this 2 that we're going to distribute out. And we also have this, we're not distributing the 4, we're going to be distributing this -1 right here. So it's this -1 that's going to get distributed out to both pieces. So this is going to give us 6x minus 4 equals 4, and then that's going to be a -3, and then when you have a negative times a negative, that's going to become plus 5x. Next, we're going to combine like terms. Nothing to combine over here, but on this side we can combine the 4 and the 3. So 4 minus 3 is just going to become 1. Okay, so we've distributed, we've combined like terms. Now we need to move our variables. We have x's on both sides. We need to have them on the same side. So we usually move the smaller one because it means we'll have less negatives to deal with. So minus 5x. This is going to become 1x, which we can also just write as x. We don't need to write the 1 in front of there. X and 1x mean the same thing. Minus 4 equals 1. And then our last step is just to add 4 to both sides, and we'll see that x equals 5. Okay? So moving on to number 3. Again, this is just kind of solving, but instead of an equation, it's an inequality. So most of the rules are going to work exactly the same way. We're going to start with distribution, just like we did up above. So 1/2 times 4. Now, half of 4, most of you probably know that that's just 2, but you can use your calculator to do these sorts of things. Don't let the fraction kind of intimidate you. We just put the fraction in parentheses, 1/2 times 4, and yep, it's the 2 that we said it was going to be. So 1/2 times 4 is 2. Now, we just did 1/2 times 4, so I'm not going to type it in again, only this time just be careful because we are going to need the minus sign there. So it's going to be 2 minus 2x is less than or equal to x minus 7. All right, so we just distributed. Next comes combining like terms, but in this problem, there's nothing we can combine. These are not like terms on the left, and they're also not like terms on the right. All right, so we're kind of stuck. Now we need to move the variable. Again, it's your choice which one to move, but I usually move the smaller one, so in this case, it is a -2. So that would mean plus 2x plus 2x. We get 2 is less than or equal to, remember there's a 1 here, so this is 3x minus 7. Add 7 to both sides. We get 9 is less than or equal to 3x. Divide by 3, divide by 3. We get 3 is less than or equal to x. Now, if you had to graph this one, which you don't, but if you did, a lot of times it's easier to have the x on the left-hand side. So then we would just do a separate step where we put the x on the left, and then it's next to the open side, so we want to keep it next to the open side, or the greater than side, and it becomes that right there. X is greater than or equal to 3. So let's actually go back up to this stage, and let's see what happens if instead of moving the 2x, you move the 1x. So I'm just going to rewrite this over here, less than or equal to 1x minus 7. So if instead of moving the 2x, you decided to move the 1x, let's see what would happen. So we'd subtract 1x from both sides. We'd get 2 minus 3x is less than or equal to -7. We would subtract 2, negative 3x is less than or equal to -9. Now, the extra part is if you did it this way, you have to remember that with inequalities, when you divide by a negative, that this has to flip around. So that would actually become x is greater than or equal to, and then negative divided by a negative becomes a +3. So we're getting the same answer. I mean, you get to the same place eventually. It's just if you do it this way, you have to remember that extra step where when you divide by a negative, it flips your inequality. Okay, so let's take a look at the back now. Number 4, find 3 consecutive integers such that twice the second is 5 more than the third. All right, so here we have 3 consecutive integers. Consecutive integers means they're right in a row, so they're only going up by ones. But here's a little key that's probably helpful. When it's consecutive, you're always going up by 1. So x plus 1, x plus 2. When it's consecutive, even or odd, it doesn't matter. They're going to be the same. It's x plus 2, x plus 4. All right? That throws some kids off that even and odd have the same let statements, but it's true. The only difference is when you're doing an even problem, you're going to get an even answer for x. When you're doing an odd problem, you're going to get an odd answer for x. All right? Now, this one is just consecutive, so we're using these right here. We can just say let x equal the first, let x plus 1 equal the second, let x plus 2 equal the third. And now we actually have to do the translation, such that twice Well, when you do something twice, you do it 2 times, so that's going to be 2 times. The second is our x plus 1, so the key here is that we remember to put that in parentheses, is our equal sign. 5 more than is a plus sign. The third is x plus 2. Now, this sometimes makes kids a little nervous because they're like, wait, I didn't use the first let statement. That's going to happen sometimes. You're not necessarily going to use all of the let statements in your equation. Just translate it piece by piece and just kind of do what it tells you. Don't go adding anything extra. So we've got 2x plus 1 equals 5 plus x plus 2. All right, so we're going to start with some distribution. 2x plus 2 equals 5 plus x plus 2. Now we're going to combine like terms. Nothing over here, but on this side we can combine the 5 and the 2. So we get 2x plus 2 equals 7 plus x. Now we need to move our variable. I'm going to go with the smaller of the two, so that's a minus x. So 2 minus, that's really a 1x, 1x, 1x. 2 minus 1 is just 1x again, so I can write that as x. I don't need to have the 1 in front of it. Plus 2 equals 7. Minus 2, x is going to equal 5. Now, if I circled my answer and stopped here, I'd lose a point because the question asks for 3 numbers. So, yes, 5 is my first number, but I need to also state that, all right, my second number is 6, and my third number is 7. All right, it's not difficult, but you just have to remember to actually answer the question that's being asked. Number 5. This is some of the new stuff that we've just started. Determine if the point negative 2 comma 5 is a solution to the equation 3y equals negative 2x plus 11. All right, justify your answer. So the easiest way to do one of these is when you have a point, the first number is your x. The second number is your y. Coordinates always have an x and a y. What we can do is we can take this negative 2 and plug it in for the x. We can take this 5 and plug it in for the y. And we're going to see if this checks out. We're going to see if when we plug these numbers in, the equation checks out. If it checks out, then it's part of the solution. If it doesn't check out, it's not part of the solution. So let's do that here. Instead of the y, I'm going to write the 5 because I'm plugging that in, equals negative 2. And then instead of the x, I'm going to write another negative 2 because that's what x equals, plus 11. 3 times 5 is 15. Negative 2 times negative 2 becomes positive 4. And then positive 4 plus 11 is 15. So we're seeing here that our equation checks out. We're getting 15 equals 15. So determine if the point is a solution. We can write yes, it is a solution. Okay. Number 6, determine the slope and y-intercept of the line 5y plus 2x equals 15. All right, so if we want to know the slope and the y-intercept, we have to get it in slope-intercept form, which is another way of saying y equals mx plus b. When your line is in this form, we know that whatever number is next to the x is our slope, and we know whatever number is by itself is the y-intercept. It's not the order that matters. It's not that the slope comes first and the y-intercept comes second. It's whatever's next to the x is our slope, whatever's by itself is our y-intercept. So to do that, if we look at our equation here, we're going to need to get that y all by itself, which means we're going to need to do 2 things. We're going to need to get rid of this 2x, and we're going to need to get rid of this 5. Those are the 2 things that are kind of in the way. So to get rid of the positive 2x, we're just going to subtract 2x from both sides. So minus 2x, minus 2x. These will cancel out. 5y equals 15 minus 2x. This is 5 times y, so the opposite of multiplying by 5 is dividing by 5, and we have to do that to everything. So it becomes y equals 3. And then if we do 2 divided by 5 on the calculator, all right, 2 divided by 5 is going to give us 0.4. And then if we math frac that, it's just going to go right back to being 2/5. Okay, so it's just going to be 2 over 5, or 2/5 x. So, based on what we were saying before, the slope is whichever one is next to the x, so our slope is going to be negative 2/5, and our y-intercept is whichever one is not next to the x, so in that case, this is our 3. So, if we were graphing this, not that we have to, the y-intercept is where we'd start, so we would start up 3 on the y-axis, and the slope is how we would move from that starting point. So in this case, it would be down 2, because that's a negative 2, and to the right 5, because that's a positive 5. Again, we didn't have to graph this one, but if you were, that's kind of how that would work out. All right, last but not least, translate into symbols. 5 times the difference of x and 3. So, if we're doing this, I think most people are going to get this first part right. They're going to be like, all right, 5 times, that's multiplication. The key is the second part, difference of. It's knowing that difference is subtraction, and then that difference of we're going to need to use parentheses. So it's going to be parentheses with subtraction in the middle, and then what we're subtracting is the x and the 3. All right, we do not flip the order. Difference is not a turnaround word. Less than is our turnaround word. So we're just going to write this as 5 parentheses x minus 3. And that takes care of that. All right, hopefully this was of some help, and hopefully everybody does great on their midterms. Have a good one.